If you carry B-positive blood, you are holding a genetic signature that is practically invisible across the Western world, a marker so absent from the populations of Western Europe that it barely registers in 1 person out of 10, and yet dominates entire nations across the heart of Asia. Not a bloodline built in settled cities or quiet river villages, but a signature forged in motion across the most brutal, exposed, wind-stripped terrain this planet has ever known. For decades, modern medicine has treated your blood type as nothing more than a hospital formality, a letter on a wristband, a checkbox before a transfusion. But when genetic scientists finally developed the tools to read the ancient code buried inside that single letter B, what they uncovered did not just change blood science, it changed the entire map of human migration. Because what the latest research has revealed about B-positive carriers is that you're not simply descended from people who survived the ancient world, you're descended from the people who crossed it. But to understand what is actually written in your blood, we need to begin with one of the most consequential scientific mistakes ever made, and the moment a century of confident assumptions finally collapsed under the weight of the evidence. The year was 1901. An Austrian researcher named Karl Landsteiner was peering through a microscope, trying to solve a medical mystery that had been silently killing patients for generations. Up until that moment, blood transfusions were an act of lethal guesswork. Sometimes the patient survived, sometimes they died within minutes, their immune system destroying the foreign blood in a violent cascade no one could explain. Landsteiner found the answer. When certain blood samples were combined, they remained smooth and fluid. When others were mixed, they clumped catastrophically. He had discovered the human blood groups A, B, AB, and O, and he won the Nobel Prize for it. But within years of that discovery, the Western scientific establishment made a staggering error. European researchers looked at their own populations, saw that A blood type was overwhelmingly dominant across Central and Western Europe, and concluded that A must be the natural baseline, the original default setting of the entire human species. Blood type B was quietly treated as a secondary variant, something that had drifted in from distant populations, unusual, foreign, peripheral. That assumption was not just wrong. The genetic evidence that arrived a century later would prove it was almost perfectly backwards. When molecular scientists cracked open the chromosome 9 gene responsible for building the antigen structures on the surface of red blood cells, they began mapping the frequency of blood type B across thousands of populations worldwide, and the pattern that emerged drew a completely different picture of the ancient world. One so concentrated and precise it pointed like an arrow at a specific corridor on the globe. Draw a horizontal band across the middle of the Eurasian landmass. Begin at the western edge of the Indian subcontinent. Stretch it across Pakistan, through the highland plateaus of Central Asia, across the steppe corridors of Kazakhstan and Mongolia, and all the way into the river systems of northern China. Within that band, blood type B does not merely exist, it dominates. In Bangladesh, roughly 35 to 38% of the population carries it. Across the northern plains of India, figures run similarly high. In parts of Central Asia and among Mongolian populations, frequencies remain consistently high across the entire corridor. Now travel west, cross into France, into the British Isles, into Scandinavia, and the numbers collapse into single digits. Look at the indigenous populations of the Americas, people whose ancestors had been completely cut off from the Eurasian landmass for tens of thousands of years, and B-positive blood has nearly vanished, almost absent entirely. In genetics, a distribution this stark does not happen by accident. It is a fingerprint, and it is pointing directly at the greatest migration story encoded in human DNA. The birthplace of the B-positive genetic signature is the Eurasian Steppe, a vast, unforgiving corridor of open grassland stretching thousands of miles from Eastern Europe deep into Asia. For most of recorded history, settled civilizations treated this landscape as an obstacle. No forests for shelter, no coastlines to fish, no farmland to cultivate. Just open horizon in every direction, savage winters, and ground that froze solid for half the year. The people who learned to master the steppe did not see it as a barrier. They saw it as a highway. Ancient nomadic cultures, the ancestors of groups that would eventually give rise to the Scythians, the Sarmatians, the Huns, and eventually the Turks and Mongols, domesticated the horse at a moment when the rest of the world was still moving on foot. They developed military strategies, supply systems, and social structures built entirely around motion. They did not inhabit a place, they inhabited movement itself. And as they moved constantly, fluidly across the entire length of the Eurasian landmass, they carried their genetics with them. What modern ancient DNA research has confirmed is that the B blood allele was not sitting quietly in Western Europe waiting to be discovered. It arrived there. Studies of thousands of ancient European genomes have found that before Bronze Age steppe-related migrations, the B allele was effectively absent in both Western European hunter-gatherers and early Neolithic farmers. It appeared in European populations alongside the genetic signature of steppe ancestry, carried westward by the same people who brought their horses, their Indo-European languages, and their pastoral culture. The geographic corridor of the former steppes still traces the B allele today. Populations along the historic migration paths consistently show measurably higher B frequencies than those that experience little or no steppe admixture. These were not populations sitting still long enough for their genetic signatures to settle into one place. They moved, and B-positive blood moved with them across a continent. But the survival of B-positive blood through that landscape was not only about geography, it was about something far smaller and far more lethal. The ancient steppe and the trade routes it fed were a biological gauntlet. Domesticated animals living in close quarters with nomadic groups created constant opportunities for disease to jump species. Shared water sources along migration routes created constant exposure to waterborne illness. And as these populations pushed south into the great river delta civilizations of South Asia, they met one of the oldest and most efficient killers in human history: cholera. Research into the relationship between blood type and cholera has produced a finding that clinical evidence confirms repeatedly. Blood type O carriers face dramatically higher risk of severe cholera disease than any other blood type. The mechanism is specific and well established. The cholera toxin triggers a significantly stronger response inside O-type cells, hyperactivating a key internal signaling molecule and driving a far more catastrophic dehydration cascade than in non-O patients. During major outbreak events in the delta regions of South Asia, places where cholera has killed for centuries, blood type O patients were significantly more likely to require emergency hospitalization and intensive fluid replacement than non-O patients. Researchers at Washington University confirmed that the toxin exerts a measurably more potent effect on O-type cells, and proposed that this biological pressure has likely shaped the actual distribution of blood types across cholera endemic regions over centuries of repeated epidemic. B-positive blood, being non-O, carries that relative protection. In the environments where your ancestors were moving and settling, down through the river deltas of South Asia into the lowlands that defeated entire armies, being non-O was not a minor biological detail. Against a disease that killed millions, it was a survival margin. But nature never hands you a shield without handing you a wound. Before we get to the most surprising twist in this story, and there is one that most doctors have never even heard of, the same blood that helped your ancestors survive those killing grounds carries its own set of costs that researchers have been carefully tracking. B-positive carriers have measurably higher levels of von Willebrand factor, a key protein in the blood clotting system, than type O individuals. A 2021 analysis published in the Journal of the American College of Cardiology confirmed that non-O blood types carry approximately 25% higher von Willebrand factor activity than O-type, and that this difference translates into a statistically elevated lifetime risk of certain clotting-related complications. This is a shared characteristic of A, B, and AB blood, not a B-specific vulnerability, but it is a real biological cost that every non-O carrier pays across a lifetime. The same blood that helped your ancestors push through the waterborne killing grounds of South Asia carries a slightly elevated baseline risk of certain clotting events in the modern world. And then there's the cultural cost, which has nothing to do with biology but is extraordinary in its own right. In Japan and South Korea, the belief that blood type determines personality became so deeply embedded in national culture that it shaped hiring decisions, romantic compatibility, and social acceptance. B-positive carriers were stereotyped as creative, independent, and dangerously unpredictable, simultaneously admired and quietly discriminated against. The Japanese even developed a specific name for this prejudice, budahara, blood type harassment. Documented cases included job applicants rejected on the basis of blood type, and relationships ended over a plus sign on a medical form. The science behind blood type and personality is not established, but the fact that B-positive blood generated enough cultural force to reshape social structures in some of the most scientifically literate nations on Earth says something remarkable about how deeply this biological marker has always been felt to matter. But just when researchers believed they had the B-positive story mapped, transfusion medicine specialists began uncovering something that standard hospital testing was never built to detect. In blood donor registries across East Asia, particularly Japan and Taiwan, scientists began identifying individuals whose blood cells expressed the B antigen at dramatically reduced levels. Not absent, not standard B, something quietly in between. These are what researchers classify as weak B phenotypes, individuals with genuine B genetic heritage whose cells produce B antigens so faintly that routine blood bank screening misidentifies them entirely. Under standard testing, some of these individuals type as group O. Under closer molecular analysis, the B allele is clearly present, expressed far more quietly than expected. Multiple documented subtypes now exist in the transfusion medicine literature, classified as B3, BX, and BM, each carrying a distinct genetic mutation, each with clinical implications for compatibility that routine typing misses completely. The B positive on your medical chart is the headline. The molecular architecture underneath it, still being cataloged in blood banks across Asia, is a far more complicated manuscript than any hospital wristband has room to describe. When you look at the full arc of the B-positive story, from the ancient steppe corridor to the South Asian river deltas to the research laboratories of East Asia mapping it today, what you are looking at is not a footnote in human history. You are looking at the genetic record of movement itself. The next time you see the letter B and a plus sign on a hospital chart, do not see a blood bank category. See what it actually represents. It is a record of a people who did not wait for the world to come to them. They crossed it. They rode through frozen steppe winters and navigated the killing grounds of epidemic disease. They pushed through mountain passes, river valleys, and lowland plains that would have permanently ended most civilizations. And they survived, not in spite of what was in their blood, but because of it. Their cells adapted, their biology held. They passed that blueprint forward, generation after generation, across thousands of years and thousands of miles, until it arrived exactly where it needed to be. In you. Your blood is not a medical category. It is the most traveled document in the history of the human species, and science is finally beginning to understand the full length of the journey it has already made. If this changed the way you see yourself, drop a comment right now and tell me, what is your blood type, and where in the world does your family come from? I want to hear your story. Thank you for being here. Stay curious, and I will see you in the next one.